During the flight of an aircraft, the pilot keeps a close watch on the many instruments before him. The proper interpretation of the readings of these instruments will help enable the pilot to operate his aircraft efficiently and safely as the flight progresses. The altimeter will be watched very closely, for it is an instrument which can be set to indicate to the pilot 3 different and important things he needs to know about during a flight. First, when a pilot requests a QNH altimeter setting by radio from a ground station, the barometer pressure reading transmitted by the ground operator is used by the pilot to set the pressure subscale of the aircraft meter. What is QNH? QNH is simply a radio signal abbreviation for the altimeter setting which will indicate the elevation of the aerodrome above mean sea level on the aircraft meter when it has landed. On a QNH, the altimeter indicates the altitude of the aircraft. By altitude, we mean the vertical distance of the aircraft above mean sea level. Important? It certainly is when you consider that on aeronautical charts, the elevation of the Earth's terrain is measured by reference to mean sea level. QNH is the altimeter the pilot determines that his aircraft is safely above the highest terrain along his route of flight. The second thing the pilot needs to know can be determined when the pressure subscale is adjusted to read 1013.2 millibars. Now the altimeter can be used to indicate different flight levels. The assignment by air traffic services of different flight levels provides vertical separation between aircraft flying in the same area. The lowest flight level assigned by air traffic services will always be the one which will ensure that regardless of atmospheric pressure changes, the aircraft flying along it will be safely above the highest terrain in the area. The last, but not the least important thing to be indicated to the pilot can be determined when the pressure subscale is adjusted to a QFE setting, relayed by radio from a nearby aerodrome. On this setting, the altimeter indicates the height of the aircraft above the runway of that aerodrome. QFE is another radio signal abbreviation, and the meaning and use of a QFE setting can be simply explained by setting an altimeter at aerodrome level to read 0 on the height scale. In effect, the man on the ground is saying, my altimeter reads 0. If you adjust your pressure subscale to agree with mine, your altimeter will read 0 when you land. Most useful information, but in addition to the value of knowing just how high an aircraft is above a runway, the pilot also wants to know his height above obstructions near the aerodrome. These obstructions in the immediate vicinity of the aerodrome are shown on landing procedure charts in height measurements above the ground level. Not all, but many aircraft are equipped with 2 altimeters. One altimeter can be made to indicate the 3 kinds of information the pilot needs during a flight, for it can be set and reset as different information is required. Generally, however, larger aircraft and those used for flights through instrument weather conditions are equipped with 2 altimeters. Let's create a flight which will illustrate how and where the different altimeter indications are used. Generally, a QNH is obtained by radio from the control tower when the aircraft begins to taxi out to the runway. The current pressure reading is set on the altimeter subscale. If the aircraft is equipped with 2 altimeters, the second one will be used to indicate flight levels. The pressure subscale on this altimeter will be set to read 1013.2 millibars. Before takeoff, let us consider the initial climb to cruising level. During the early part of the climb, the pilot will want to know his altitude. But later, he will use a flight level reference. A change of altimeter reference is therefore made at a fixed altitude. This is called the transition altitude. It is usually about 1,500 feet above the aerodrome level. The position is determined for each area. Now we are ready to follow our flight. At first, the pilot refers to his QNH altimeter and reads altitude. Then, on reaching the transition altitude, he refers to his flight level altimeter as well. In this case, the pilot sees that he is approaching flight level 20. All reports to ground stations are now given in terms of flight levels. During this flight, the pilot will fly the aircraft at flight level 50. While cruising at flight level 50, he will also watch the altimeter set on QNH in order to check his altitude above mean sea level. Comparing the indication of this altimeter with the elevations shown on aeronautical charts, the pilot is able to determine his vertical terrain clearance. If the aircraft is flying into an area of rapidly changing pressure, the QNH setting will soon be in error and no longer apply. The altitude of the aircraft above mean sea level will be incorrect, and the terrain clearance will not be what the pilot thinks it is. He should therefore obtain a new QNH setting from a station closer to him. As each new station comes within range, a revised QNH is obtained. This flight, however, goes over an area where there are very few surface stations. Adequate terrain clearance in this area has been assured by the selection of a safe flight level before takeoff. So the pilot continues to cruise along flight level 50, referring to the altimeter set on 1013.2 millibars. Because all aircraft flying in this area have their altimeters set on 1013.2 millibars, our pilot at flight level 50 also is assured of adequate separation from aircraft flying at different assigned flight levels above or below him. When the flight has progressed to the area where a landing is intended, a new QNH setting is obtained from the aerodrome. At the same time, the current transition level above the aerodrome is obtained. On this day, the transition level is at flight level 40. Let us now look ahead to the situation at the aerodrome. The transition level is the lowest usable flight level above the fixed transition altitude. In this case, the transition altitude is 4,000 feet. Since the aerodrome elevation is 2,712 feet, the transition altitude is 1,288 feet above the aerodrome. The transition level is 319 feet above this. All aircraft at or above the transition level report in terms of flight levels, while aircraft at or below the transition altitude report in terms of altitude. The pilot now descends to the transition level. When cleared to commence the approach, the pilot leaves the transition level and changes his reference to the QNH altimeter. This altimeter now indicates altitude above mean sea level, and the pilot can determine the aircraft's terrain clearance and elevation above the runway. The pilot could complete the final approach using only this QNH setting. But he also asks for a QFE setting from the aerodrome controller for the final approach and landing. The pilot resets the subscale of the flight level altimeter to the QFE value given him, and this instrument now indicates the direct height above the aerodrome runway. When the landing is made, the QFE altimeter reads 0, and the QNH altimeter reads very close to 2,712 feet, the elevation of the runway above mean sea level. Safe terrain clearance and adequate vertical separation depends in part upon the pilot's knowledge of how to use the different indications of his altimeter, the cooperation from his colleagues on the ground, and finally, the realization by the pilot that the aircraft is always flying through a restless, constantly changing ocean of air, which may alter the indications of the altimeter.